Data visualization is an essential component of a data scientist skill set, and Seaborn is one of the most popular packages in Python to implement data visualization. Keeping the importance of Seaborn in mind, we have come up with this Seaborn Python tutorial. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset, and we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset. And I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in sns.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to. So here, if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. And we'd have to load the required libraries. The first library is obviously Seaborn. So I'll have import Seaborn as SNS. Then I'd also need pyplot. So I'll have from matplotlib import pyplot as PLT. Let's just wait for these 2 libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have sns.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI, and I will store it in this object called as fMRI. And let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present. And I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. sns.lineplot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'll actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20 and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2, and when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of queue event is much higher when compared to the increase of the stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the queue event is being represented with this dotted line and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the Seaborn library. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this is legendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as PD. Now once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in pokemon.head and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this is legendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this is legendary column and then the speed column. So I'll be using sns.barplot, and onto the x-axis, I would have to map is legendary, and then onto the y-axis I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out, and when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between is legendary column and weight in kg column. So is legendary column is again mapped onto the x-axis. It's just that here for the y-axis we are mapping weight kg column. And this time it is very obvious that legendary Pokemons, their weight is much higher when compared to non-legendary Pokemons. I'll cut this out, I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column, and we already know to do that we'll be using the hue aesthetic or the hue attribute, and I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary, this denotes all of those Pokemons which are legendary, And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these three different palettes over here. So again, the bar plotter is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette. And we can directly use different predefined palettes. So first we have the Blues D palette with a capital B. This is how it looks like. Then we have the Rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute. And the first palette which I'll be using is Blues D. And as you guys see, this is the Blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the Rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette I'll have the color attribute, and I will set the color of these two bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between two numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up. Then we'll be using SNS.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got 3 different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got 3 different styles over here. For Setosa, we have solid circles, for versicolor, we have crosses, and for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add two more attributes. The first attribute will be hue, and onto hue, I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital, and when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column, and you would see that we have three different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses, and for Virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram where it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use dist plot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head, and these are the different columns which are present. So I've got carat, which obviously tells us about the carat of the diamond. Then we've got the cut type of the diamond, we've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters, Y denotes the width of the diamond in millimeters, and Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot, and since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.dist plot, And inside this, I'll be passing in diamond. I'll have square braces over here. Inside this, I'd have to pass in the column, which is price. And I would just show this out. I'll have plt.show. And you would see that I have created this distribution plot over here. Now, in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created, and to this, if I want to add color, I'll use this color attribute. I'll assign it red, and you would see that I have assigned it the red color. Now if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10, and I'm just setting the color to be equal to green. I'll select this over here, I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50, and as you guys see, I have only 50 bins. Now let's say instead of 50, maybe if I want only 10 bins, so you will see that I have only 10 bins. Now let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here, and here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next, we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center, and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we are just use scatter plot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatter plot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about joint plot. We already have loaded the iris data frame. Now I'll have to use sns.joint_plot, and onto the x-axis I'll be mapping sepal.length, and onto the y-axis I'll have to map something. So onto the y-axis I'll be mapping petal.length, and that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, so seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center, and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, that is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute, and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values, and also it is passing through both of these histograms. So here I'll have kind, and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Once I have done this, let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company, and on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv, and then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column which would go on the y-axis and this churn column which would go on the x-axis. sns.boxplot, and onto the x-axis I'd have to map obviously the tenure column. Onto the y-axis I am mapping the churn column. Then I'd have to use the data which is churn, and I'd have to show it out. So I'll have plt.show. So I've actually made a mistake over here. So tenure will go on to the y-axis and churn will go on to the x-axis. Now we get this box plot. And we've already seen the inference. It seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these three different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these two boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here, but on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service, and this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have three different types of contracts: month-to-month contract, 1 year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. If we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width, and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2 year first, followed by month to month, then after that, if I want 1 year, then I can use this attribute called as order, and inside this I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here I'll remove the line width, and instead of line width I'll use this attribute called as order, and first I'll have 2 year. After that I'll have month to month. Then finally I'll have the last box which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. and I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here I'll add this attribute called as hue, and I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories. This brings us to the end of this Seaborn Python tutorial. Now before you guys sign off, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. Thank you very much and have a great learning ahead.